Looks like the steel is finally coming down. Jamie's got some equipment, a lift, looks like a telehandler, and a couple of flatbeds to haul all this away. He's going to have a job ahead of him cutting all these welds. Already stomped out a couple of brush fires from it. Jamie is the gentleman I bought the trolley beam from, so very grateful for that. He has a bunch of old stuff in various fields, pieces of steel. He has some nice things that would make some column style jib cranes, just a matter of affording them. But we'll see how this goes over the next couple days. Well, this is the first production job for the K&T. And what I've got to do is work on this differential cover. Now, my son Brennan has a channel called The Facility, and one of the projects he's working on is turning a 1974 Spitfire into a hybrid, well, kind of a hybrid. He's remotoring it with a Volkswagen 1.9 liter TDI turbocharged diesel, coupled to a T5 transmission through a bell housing that he got from the UK. And at the rear end, he's replacing, he was originally going to go with a GT6 rear end, which was a little bit more capable in the way of handling torque, but he changed his mind and he went with a Datsun something rear end, which had, I believe, the capability of doing limited slip and had more ratios available. So one of the aspects of this is that the differential on the Spitfire is somewhat structural, because the transverse leaf spring mounts to brackets that attach to the back side of the differential, and he had to make a replacement rear cover. Original rear cover to this Datsun transmission is cast aluminum with internal ribbing, and it has clearance for the ring gear, but he had to make a cover that matched with bushing holders to fit the Spitfire chassis and internal clearances for the gears. And one of the things he did was he improved the ventilation of the differential case. He's got a little hole drilled in there, and then he's got a porous pipe. This is some kind of a commercial ventilating fitting from McMaster that has just a porous stainless steel mesh here. And the way that the Spitfire ventilated the case was they drilled a hole in it and put a cotter pin loosely into the hole to prevent mud daubers and such from plugging it up. So that was kind of a cheeseball way, but factory 1974. This is a little bit better. We've got a drain fitting. Now, the issue he had was, of course, doing all this fabrication on top of a 1/4-inch steel plate. This is no longer flat. Let's look at what happens to a piece of steel when you put a weld on it. We started out with a flat plate, 1/4-inch plate. I'm exaggerating the thickness, but we're all flat and happy. There's no stresses basically on this except what might be inherent in the steel as it comes from the mill, but for all intents and purposes it's flat. Then we go and we start welding stuff onto one side, and we have a boss here, and we're putting a fillet there and a fillet there, and we're putting welds. Well, what happens? These welds shrink and then this plate bows. So what we end up with is something that looks more like this. This is our plate, greatly exaggerated. And in order to bow that plate, we've made one side longer than the other. And all of the metal up near this edge, all of this metal is in tension. And all of this metal along the bottom edge is in compression. Well, now we come along and we say, we want this surface flat again. And so we start making cuts on this surface. And you can see how it starts out. And then we cut a little deeper. And then we cut a little deeper yet. Well, you can see what we're doing as we remove material is we're cutting into the steel that was in tension, and we're leaving this alone. Well, this plate has to rebalance itself, and what does it do? It bows a little bit more. So instead of having a flat surface, what we actually have is we have a slightly crowned surface. This is after we've cut it. Eventually we'll get down to a point where, we've gone from this corner to this corner. And we think that's flat, but because we've removed material on the tension side, this is still bowed. And if you want to go, to the degree of looking at it in the thousandths of an inch, we still have a bow. You'll almost never get this flat. Now, before you make any of these cuts, if you were to stress relieve the weldment, put it into a furnace, get it glowing for a half hour or an hour, relieve all those residual stresses, then when you start cutting it, it's going to stay pretty flat. But it's something the fab shops hate to do. In my experience, if you want to hear a fab shop moan and whine, just tell them they've got to cut and machine a surface after they've welded something up. They absolutely hate to do it, but when you want to put this differential cover on another flat surface, it has to be flat. You just can't leave it as welded. And it's a little bit difficult for me without a lot of measuring capability to determine how out of flat it was. But basically I was able to determine that it's somewhere between 65 thousandths and 78 thousandths based on these two drill bits that have to come off. And this is humped up mostly in this direction. We got a little bit of a bow side to side, not as much, but we're going to be bringing out the most of the material along this and then tapering off, trying to remove as little as possible out at the edges. Challenge number one, how to hold this thing. The vise I have, a 6-inch vise, which is borrowed, won't work because this dimension right here is about 6 1/8, and it just won't open up far enough. But I've got an 8-inch vise coming, and basically what I'm going to do is set on this surface first, and then I'm going to dust this off, flip it, square this, because these edges are no longer parallel. They kind of sit down like this in a V shape because of the bowing. And then I'll be able to put this in the vise like this. Might end up supporting either end on some little standoffs, but I can put basically the two bushing mounts flat on the bottom of the vise. And then I'll just tram everything, try to get this running around the bolt circle as flat as possible, and then walk this back and forth. I think I'll try to take off most of the material with my 3/4 inch. It's a rougher finisher that has a 45-degree chamfer on the bottom edge, so you can surface with it and not affect the diameter, as long as you don't cut more than about 50 thousandths deep at a time. But I'll take off the bulk of the material with that, and then probably switch to a fly cutter and try to get them a nice smooth back surface here. So let's set it up in the mill and get machining. I lost the footage of the initial milling I did on the sides of the cover, but we'll pick up with what I started with the new 8-inch vise here, which was way too heavy to manually lift off the tailgate. This vise was way too heavy to lift just by hand, so I had to use the overhead hoist to sling it and just drive out from under it. Had a little temporary bench I had to set it on, and one of the first things I needed to do was verify that it would clamp the new differential cover, which it did. So I started by moving the old vise and cleaning and stoning the surface of the table where the new vise was going to sit. Also took the opportunity to vacuum up chips from the previous jobs. Once I had the table prepped, I had to get the new vise overhead and clean and stone the underside, make sure there was no burrs or projections on the underside. It looked like it was in really good shape. So moved that over, got it positioned on the table, and started to get set up for tramming in the vise jaws. Tramming everything in was pretty straightforward. I started off at the top edge, moved down to the bottom edge, and got everything in within about a half a thousandths. But I noticed that there was a little bit of a dip in the center of the vise, so obviously from people clamping work, dead center, it dipped in about a thousandths and a half or two.
I'm within about a half. So I'm going to give these a little snuggie. Run it back the other way.
I had a couple of little sheared off round bars. They were some kind of handle weights, and I decided to mill these to use for standoffs to set the height of the differential cover. I needed 3-point contact, so the two round posts served as two of the standoffs on one side. Then I had previously milled a small scrap of 1/4-inch plate to serve as the standoff for the other side. And all of these I did an 1/8 inch shorter than the height of the vise jaws. To set the height, I used the 1/4-inch plate as a like a reference, and then I brought the cutter over, hopped over the top of the round standoff, and then brought the quill down until I was touching off on the previously milled 1/4-inch plate. I went up and down a few times because it took like 3 or 4 cranks of the quill feed in order to get a good reference as to what the actual measurement and stopping point was for the quill travel. And then I decided to mill the excess off the length of the round stock in basically one shot. So there's a couple of ways I did that. The first one, I roughly zeroed the head of the machine over the center of the round bar. Then I just offset the head and started walking a circle around the round bar, which took obviously more off at some points than others until I was cutting everywhere, because I didn't indicate this with zero it with an indicator. I just wanted to start from the outside and mill my way in and leave a post standing up in the middle. And I did that to see kind of how the machine, how accurate it was in milling a circle. There's some super slow-mo of the chips, but I wanted to see how small of a post I could mill and not have a taper in it. I went round and round, taking maybe 30 thousandths or so of a pass each time until I got down to about an 1/8 inch diameter left on the post.
Now, I didn't zero it, but I just milled in a circle, and that's about a 1/2 inch projection. .121.
I was curious both how stiff the pin was and also how round I was able to keep it, just milling a circle like that round and round. And once I was satisfied and made a reasonably cylindrical pin, I just stepped over with the cutter and milled it off and continued to make that surface flat. For the other standoff, I just went back and forth with the cutter, stepped over a little bit, and milled it
directly down to the finished height, which went a lot quicker than playing around with the rotary head. For this differential cover, I have 3 standoffs I made. I made them within 0.02 of each other. I've got a scrap piece of 1/4-inch plate on this side, and I've got 2 round posts on this side. Like I said, they're all within 0.02 of each other. I'm gripping about an 1/8 inch on the vise. I've touched off. I'm going to come down 0.10 and start cleaning up this surface. And as you can see, that side is not as low as the middle. Got a 3/4 inch diameter cutter, but because of the chamfers on the edges, I'm using a 1/2 inch increment on my step over. I'm going to increase our feed speed to 7.5 inches per minute and come down another 10. Still nothing on this side, which is fine. Come down another 10. Very nice. On the next pass, I'm going to go 15. Don't want to put too much cutting forces into everything, but everything seems to be going pretty good, so let's go a little bit more. All the back and forth really took quite a bit of time. Not so much from the travel speed, but either end of the recess there for the ring gear, I had to go back and forth and backtrack. So didn't want to put too much cutter forces into things. I kept the cuts at 10 or 15 thousandths deep. I'm going to go back to a 10 thousandths cut. Final 10, and I think we'll be there. Well, in my judgment, that's good enough. He said take off as little as possible. Plenty of area here on the gasket surface for that to seal against. I'd have to cut the whole surface to get another couple thousandths here. So we'll call that done. I think this is a problem they didn't anticipate. Once loaded with steel, their trailer kind of sunk in. That's a lot of weight now to try to lift up. I hope it comes up high enough to where I can get the cab under there. We will see. Well, it's all gone. Loading up the equipment, getting ready to move out. I think that turned out rather well. I'm not worried about this area right here. Plenty of surface that it's going to be clamping on, and really it needs to seal inboard of the bolt circle anyway. You can kind of see how we're a little thinner here, more so on this side. But I checked it with a straight edge and it's pretty flat. I don't know the orientation, but here's the piece that it's replacing. And you can see the clearance for the ring gear was basically in that area. That's what he had to duplicate there. So he's good to go. Hope you enjoyed that. Got many more projects coming up for the K&T Rotary head mill.